Hey guys, welcome to Great Learning. Now, cloud computing is a domain that is being integrated with every other domain in the world of information technology, right? Think about it. Individuals to multinational corporations who are worth trillions and trillions of dollars, everyone is looking forward to using a lot of cloud computing going ahead, right? Now, this is only possible just because of the fact that there are many cloud service models such as infrastructure as a service, platform as a service, and software as a service, right? IaaS, PaaS, and SaaS in short. Now, these services are giving developers unparalleled customization options regarding how they can go on to build and deploy using these cloud computing platforms, right? Now, the domain is improving at a pace which we have never seen before, and it becomes very important that all of you all have thorough knowledge on these service models, right? So keeping exactly that in mind, we here at Great Learning have come up with this course on platform as a service, or PaaS as it's called in short, to give you guys an in-depth understanding of the same. Now with that, I know you guys are super excited to get started. Well, what are we waiting for? My name is Anirudh Rao. Let's get started.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so to quickly give you an idea about what we're going to be covering in this course, PaaS and cloud computing, we're going to begin by understanding and having an introduction to cloud computing. Now, understanding how cloud computing works and what are the various types of cloud deployment in terms of public clouds, private clouds, hybrid clouds are very important for you, because when we go on to discuss the various services that are out there and how we can best use these services in the combination of various deployment models, you guys will have a complete knowledge about what patterns you need to match between deployment models and services and how best you guys can use them, right? So we're going to be discussing the introduction to cloud computing, the various types of cloud deployments there are, and of course we're going to be taking a look at all the three types of cloud computing services really quickly. We're going to be looking at infrastructure as a service, platform as a service, and software as a service, right? Now once we are done with that, since in this course we focus on platform as a service, we're going to be taking an introduction to PaaS to understand what it is, how best it works, in which situation you would want to use PaaS and all of that. After that, we're going to take a look at the various types of PaaS that we have in today's world. And of course, once you understand all of this, the first thing you're going to be doing is you'll be very curious to see who are some of these providers out there who are providing amazing platforms for PaaS. So we're going to be taking a look at that. And to round everything up, to round your entire learning, we're going to be taking a look at understanding what you should consider before choosing PaaS, right? Now, we'll also have a look at IaaS, SaaS, and PaaS, but there is a very good chance that sometimes you might have to think about a lot of things before finalizing a model. So we're going to be wrapping this course up by giving you a complete picture of why, when, how, and why you should even consider to use PaaS while you have many other options, right? Fantastic. With that, let's begin. We can actually get started with what is cloud computing. Now, whenever you think about cloud computing, the most important thing that would come into your mind, the first thing that would pop up in your head is probably an operation as simple as backing up your photos to your Google Drive or something like that, right? Back in the day when cloud computing started out, this was actually the case. When users started using it, when it was started to put to commercial purposes, at the end of the day, it gave very little room, very little freedom for what the end user could do. But today, if you take a look at cloud computing, you can back up your photos, you can have entire companies run, Fortune 500 companies and companies worth trillions of dollars. You can have the infrastructure, the entire setup on cloud computing platforms, and run your companies directly from there, right? So what is cloud computing if it's this powerful? Well, cloud computing is basically a concept of wherein you will have servers, you will have a lot of physical infrastructure all around the world through which you provide services, right? Now, when I say services, you might have heard of this concept wherein you might be backing up a couple of things to your office server, right? Your office server is nothing but an entity that is sitting on premise, that is sitting right next to you in the server room in the same building, same city, or something like that, right? In the case of cloud computing, what happens is that there are servers similar to that, but it is exponentially more powerful and can handle way more number of clients, and it is strategically located everywhere around the world, such that when someone in the US has a requirement, they have a server there to provide for that. Someone, let's just say in Egypt, has a requirement, they will have a server nearby there to make sure that they can have access to any sort of services, right? You can build and deploy machine learning algorithms, you can have a variety of storage, you can perform real-time computational analysis, and you can do a lot more with today's world of cloud computing, right? Back then, it was just backing things up, it was just ensuring that you were using a server to basically have an extra point of storage, a redundancy in case something fails. But today, having an on-premise server is for that purpose, right? So having an on-premise server is meant as a backup while having your entire company work on the cloud platforms like AWS, Azure, or GCP is the trend. You would have seen this entire trend reverse, because what those guys are doing, the services, the tools, the techniques they're offering to their platforms at a very, very competitive price in today's world, what makes these companies actually go on to prefer that, right? So at the end of the day, our discussion should be, why should we even require cloud computing in today's world? The first thing you have to understand is that we generate a lot of data in today's world, right? Now, I just made that sound. I just snapped my fingers. By the time you actually heard the snap, we would have generated terabytes worth of data, hundreds and hundreds of terabytes worth of data by the second you heard that sound. Now, when the world is generating so much data, and the world has also realized that data is almost like fuel, right? You can use it and you can drive so many things with it. Back then, probably 15-20 years back, when we generated a lot of data, it was archived and maybe it was destroyed later on. But these days, people realize that even something which might have a small impact on your business, if analyzed to a good amount of depth, has a profound impact, right? So considering that, data is transforming the way we work, and of course in today's world, the way we work with the data itself is transforming in a way where we're generating so much, right? So having the ability to move entire companies and work from the cloud, having access to their extremely fast data storage methodologies and super powerful processing machines are what will give you an edge over your competition, right? Think about it. And it's not just this. Back in the day, we were limited to the amount of services that you could access via these cloud computing platforms. But today, you can, I just want to say this, you can do almost everything, right? 99.9% of what you would do on an on-premise network, you can do it on the cloud. Sometimes it is considered to be even more safer, even more robust, and at the end of the day, the rate at which it might fail or it might cause issues is coming down with every single day, right? But the biggest advantage of why people are considering cloud computing, to be very honest with you, is the last point there. The pay-as-you-go policies, right? Now, pay-as-you-go is a concept as in you will only pay for what it is that you're using. Let's just say you have a requirement wherein you require a virtual machine for 20 minutes to operate on a certain load, right? You have a load and you want to use it for 20 minutes. Now, let's just say you don't have any hardware at your home or your office. What would you do in this case? You would go to your shop, you would purchase all the hardware, get it all set up, find a person to install everything for you, all the software, and eventually find a person to maintain all of that as well, right? But with cloud computing, it's a few clicks of your mouse, and guess what? The initial investment that you have made for an entire computer, which you'll probably need only for 20 minutes, and later it might just be used for something else. But in the case of cloud computing, you're only allocated that computer for that amount of time, and you only get to pay for that much, right? That is a fraction of the cost of what it would actually cost to buy an entire computer. Now, similarly, just enlarge this idea 1,000 times or 1,000,000 times, and you would understand how much money you would actually save doing this. It's not just money, it's a lot of headache running a lot of servers, because at the end of the day, it's not just buying these servers, it's about maintaining them. It's servers, right? It will tend to go bad. It'll have a lot of hard disks, and hard disks go corrupt every now and then. And it's not just that, you'll be paying electricity bills. You have to make sure it's compliant with your fire hazard standards, and at the end of the day, you have to also cool it enough such that it doesn't melt or doesn't burn up or something like that, right? So all of this headache will eventually cost the company more time and more money. But if you can offload all of this to say, hey, I want someone else to take care of this, I don't want to be bothered by any of these, I want to spend my time, I want to spend my vital time actually working on my application. That is important, and that is one of the reasons why cloud computing is so popular in today's world, right? Now, after that, you might be asking a question saying, hey, Anirudh, okay, that's fantastic, but how does this domain work? How does the domain of cloud computing actually work? Now, when you take a look at understanding cloud computing, you'll have to basically divide it into two divisions, all right? One is the front end, the other one is the back end. Now, when we say front end and back end, right now, wherever you're watching this video, you basically are looking at the front end side of things, right? Front end is where you have a user interface through which you can directly access a video that is stored again in a server, which can be right next to you or which can be thousands and thousands of miles away from you, right? But it is giving you a feel as though you've plugged in a USB into your computer right now when you're watching the video, right? But it's only the front end that is making sure that you have this user experience while the actual data gets stored elsewhere, and all the things that is needed for the communication between your front end and back end is also important and present, right? So front end is such an important concept for cloud computing, because at the end of the day, user experience is what matters a lot for all of us, even in the most mundane tasks that we do, right? Think about social media. Way back in the day when Facebook came out, when its first version went viral, went public, and everyone was switching from Orkut to Facebook, you would realize that it was nothing fancy. It was amazing. It was going good. But compare that interface to today's Facebook interface, right? A million things have changed. Of course, some of you can argue that a couple of things were better then, a couple of things are better now. All of that is a separate discussion. But the user experience you get even from social media applications will want you to spend more time there. It will want you to explore a lot more. Cloud computing is very critical in this aspect, because you will have a variety of developers, variety of users, clients, everyone who may or may not have used a cloud computing platform ever in their lives before, right? So considering everything, the goal of a cloud computing platform is to ensure you have a great front end, not only to use the platform, but at the end of the day, when you are creating applications and deploying them on the platforms, those also get to have very good front ends, right? So front end, regardless of where it is, web development, data science, cloud computing, no matter what domain you look at, one thing you have to understand is that it is super critical. Coming to the backend is where again all your data is stored. It is literally like the heart of heart of cloud computing, wherein everything that's necessary for it to work is right there, right? So let's quickly explore front end and back end a little. As I just told you, front end is what actually helps the users have access to all the data that gets stored, right? Now the data is stored in the back end. The actual data is in the back end, but it gives you a feel as though you're directly connected to the back end. In many cases, you directly are, right? The front end does not just give you a user interface, but it has a direct impact on your user experience as well. So understanding that what you see is not exactly how a server would work. A server would work, it will take a lot of programming, a lot of database knowledge and everything to get it run and set up and all of that. But at the end of the day, you wouldn't want everyone to do that, right? If you just have a backend running, separate all the complex procedures, give the user a good front end to work with, that is a win-win situation. Think about it. Right now, when that is done, the next thing that comes into the picture is the actual backend. Backend, as I just told you, is where all the data gets stored, where all the servers are there, where everything needed to run these servers, power, cooling, whatever it is, right? So the backend is literally, you might have seen videos of these data centers and all of that, right? And if you haven't, I really suggest you head to YouTube and check them out. All these giants such as Google, Amazon, even Facebook for that matter, all these guys who generate a lot of data and have to handle a lot of data, they have data centers which have so much security, and you'll understand the amount of care that goes in while you actually take your data to a provider and say, hey, I want to take I want to store my data in your platform or something like that, right? So if there's this very simple operation of you actually analyzing data to create some beautiful looking graphs or something, a beautiful division between the front end and back end is basically you actually showing the graph is on the front end, right? Maybe you're in a meeting, you just want to show the graph and say, hey, these are the data points I used to get to this graph. That is the front end. But all the data that is required, all the analysis that goes into the data, and the actual creation of the graph, where do you think all of this happens, right? So all of this happens in the back end, and it is very important for you to analyze this. Okay, that's good. So we discussed the front end, we discussed the back end, but how do you get the front end and the back end to talk? Is it as simple as just running a couple of wires or something? Not really. So basically we have a software, in fact we have multiple softwares called as middlewares. Now middleware is nothing but a platform that acts as a bridge between two or more applications or two or more devices, right? Now, whenever you are using the front end to connect to the back end, again, as I just told you, it's not a simple connect of a wire or something. This sits as a bridge to ensure that at the end of the day, you have one server wherein you can have multiple clients connect to it, in fact, at the same time, right? That's how the world works. So this software which acts as that bridge, this software which acts as a connector through which you can have access to these servers, services, or anything as such, is very important for you to understand. Getting your front end vitally to talk to the back end, and any request that is basically made by your front end, when your front end says, hey, the user clicked this button, now I want that task to happen, your front end will tell that to the back end. Your back end is like, okay, if that's a valid task, I'll do it for you and I'll show you the result on the front end again, right? These operations, now a very simple click of you guys entering your email ID, password, and hitting login button, maybe on your Gmail or something, right? When you hit login, it's a front end application that you're basically trying to use, but as soon as you log in, it has to go to those servers, check if your username is correct, check if you've entered your correct password and all of that, and eventually come back to tell you if everything was correct. And if everything was correct, you log in. If everything wasn't, you don't get to log in, right? So that is something which is important for you guys to understand. After we've discussed all of this, you'll be very curious to understand what are some of the types of cloud deployments that we have in today's world. Well, to answer the question, we have four very important types of cloud deployment today. It's the public cloud, the private cloud, the hybrid cloud, and the community cloud. Now, even without, presuming that you might have never had any experience with cloud computing, as soon as you take a look at that, don't you think you can guess what it might do, what a public cloud is, what a private cloud is, what a hybrid cloud is or something? Just think of your favorite cafe or something, right? If someone says, hey, this is a public cafe, it means that anyone can walk in, anyone can have a have a coffee there and walk out. But if someone says, hey, this is a cafe, but it's only private, it's only meant for the employees of this particular building or tower or something like that, there you must have some sort of access or authorization to actually get into that, right? Similarly, the cloud works there as well. But when you say hybrid, people say that, hey, so maybe not outsiders cannot walk into this particular cafe, but maybe the people who stay in these apartments can walk into this cafe and have a coffee and go, right? Think about that. That's hybrid, right? People outside maybe just one apartment building are still coming, and you have multiple apartment buildings where you're saying if you're part of this and this, you can actually, it almost seems like it's private, but when we actually explain the concept of hybrid, you'll have a better understanding. And then it's the community cloud, right? Let's actually get right into the heart of these to talk about what each of these mean, because in the context itself, I'm sure you will have a better idea of what they are. Right? Now, to talk to you about public cloud is a super popular form of cloud deployment. Now, the infrastructure, right? Think about the examples on the lines of AWS, basically Amazon Web Services, Microsoft Azure, and even the Google Cloud Platform. These are public clouds. As in, if you can log into their platforms, anyone across the world can actually start using the features provided by this provider, right? The infrastructure is provided for all, and it can be shared among all the customers as well. So it doesn't mean that if there are 7 billion people using cloud computing, it doesn't mean that there are 7 billion servers out there. There could be just a handful of servers which have the capability to handle this huge amounts of load and all of that, right? So there can be cases where, in the case of public cloud, where there's a team who's working on software development, or there's a team developing a couple of projects which will require collaboration not just within the organization but maybe on the outside as well, right? So having public cloud again has its own advantages and disadvantages, but in today's world, having the access to say, hey, this is not a research topic, this is not something which is classified or something like that, right? People have access to it. You and me as absolute individuals can in fact launch an entire company if we want to on the cloud computing platform, and you have the facility to do that. You have to thank public clouds such as AWS, Azure, and GCP, and of course there's a lot of other people as well, but you have to thank them for this ability, right? So the biggest advantage of public cloud, in my opinion, is the fact that you have the pay-as-you-go model. Regardless of any type of cloud, in my opinion, having the access to pay-as-you-go model is something that's going to save a lot of effort, a lot of time, a lot of resources for the company, right? Think about it. Why should you have to pay for something in full, knowing very well that you might be only using it for a short amount of time? Think about the PC example that I gave you, right? Let's just say you're into video editing or something, you require a very powerful machine right now to use it, and you'll know that, hey, I'll only use it for 1 day, 1 week, or 1 month or something like that, and after that it's your heavy initial investment, and you'll know that I might not be able to use this anymore, right? Because maybe your project ended or something like that. In that case, what you would do is you would jump onto the cloud computing platform. They have a ton of, all these cloud computing platforms in today's world have a ton of really lightning fast computers out there. Depending on what what level of speed you require, how many clients will access your application, what is the amount of resources you require, you can map each and every single thing and just pick up that and just pay for the amount that you would have used, right? If you've just use something for 1 hour or 2 hours or something, you would only pay for that. Now, with this comes another huge advantage. One, you're of course saving a ton of money, but the second thing you also have to look at is that you'll be creating highly scalable systems, right? Today you have an application which 10 people are using. Tomorrow it might grow to 100. Day after it can be 1,000. And maybe 3 months from now, your company just went viral and there are millions of people flocking towards your brand. When that is the case, your servers, if it is probably in-house or on-premise or something like that, you would have to go out to buy new servers, upgrade all your network modules and all of that, because you wouldn't be able to handle that amount of traffic. But with respect to these platforms, you can never overwhelm these platforms, right? No matter how much traffic you bring in, the platform has more to offer, right? It's almost like an infinite funnel, and it will keep providing the resources that you would require. That is how big today's world of cloud computing is. But with respect to cloud computing, in terms of public cloud, you have to understand one thing is that if you are looking for complete control, end-to-end control of your product, your application, and your platform, it is not possible, because if you've deployed your company on AWS, if you've deployed an application on Azure or something, how Azure works, and there's a very good chance that one or two servers might go down there as well, right? So that control you will not have, and that is an important thing which you should know about. With that, we can discuss about the private cloud, because the private cloud, these have been in use for a really long time right now, because whenever you think about certain companies running their own servers, running their own farms through which they have a ton of servers, and people of that organization only access to those servers, right? So these are private clouds, and these have been used for a really long time, as you could guess right now, and they are used, let's just say, by only one organization, right? But of course, since it's connected to the internet, internet, if you're an employee of so-and-so organization, you can sit at the end of the world, at the other end of the world basically, and still connect to it with your email ID, password, or any other authentication protocol that they have, right? With respect to a private cloud, one thing is that you're not sharing your resources with anyone else. With respect to public cloud, that happens, right? One server can be used by 3 or 4 companies out there. With respect to private cloud, it's only your employees, your officials who are using that, and it is completely owned by the company themselves, right? So you're responsible for just buying the infrastructure, maintaining it, ensuring it runs well, and at the end of the day, everything that is required to keep those servers up and running is at the company's end. Now, with this, there come certain advantages and there are certain disadvantages. The advantage is, of course, the fact that if you're a person who says, hey, my data, the security for my data is the highest priority. This data is, it's classified. I don't want anyone else apart from the people in my organization to see it, and I don't want to be sharing servers and storing this in public domain. In that case, you can actually have a private cloud setup wherein people only, with respect to your organization, will have access to that, right? And you can, inside the organization also, you can say, hey, people with L5 access, L4 access, level 4 basically, have access to this, and anyone below L4 will not have access, and they cannot work with these servers, right? So that is critical for you to understand. Outside the organization, you can block all traffic. Inside the organization, based on authentication, again, you can still do that. But one disadvantage here is for the fact that you lose that versatility that you have with respect to public cloud, right? And the most important thing you lose is the scalability factor. As I just told you, if you have on-premise servers and private clouds running, today you have 1,000 people, tomorrow you have 3 million people, your servers will crash because they were never meant to handle 3 million people. But if you initially spent out a ton of money to say, hey, I know I might get 3 million people, so let me just buy it all right now, again, it would have cost you a huge amount of money to buy that, and at the end of the day, after 3 million, maybe you can hit 10 million as well, right? And the remaining traffic cannot be handled. There again, your scalability has taken a huge hit. With respect to public cloud, this problem is also solved. But if that extra security, if security is your number one priority and you say, I don't care about anything else, security is what I want, private cloud is something you should look forward to, right? Superb. With this, we can take a look at the hybrid cloud. Hybrid cloud is considered to be the latest standard in cloud computing. I'll tell you this, because hybrid cloud is nothing but a combination of public clouds and private clouds, right? Now, there are certain companies who will say, hey, we have certain information which we don't want to put on the public cloud. We will have our own private cloud sitting at our office where we'll have all of these extremely critical information bits which we won't share to the public cloud, which we will have across the organization. And we also want to make use of certain perks that you're providing as a public cloud platform, and maybe have a front end there, maybe try to do something wherein your server talks to those servers and all of that. So if a company comes with a requirement such as this, you can use a hybrid cloud wherein both your on-premise private cloud and the public cloud can work hand in hand, right? But with respect to private cloud, as you already know it, it cannot grow up to the demand. It cannot meet certain demands as much as a public platform would do. But what the advantage of hybrid cloud is that you can use all of these capabilities that public cloud is known for. Scalability is the most important thing, right? You can literally use that amount of scalability and say, hey, if there's any heavy lifting to do, and if I know that my private cloud cannot handle any of these, great, I'm going to just move all of these heavy lifting tasks to the public cloud. And again, with a couple of mouse buttons, you can have any sort of power, any sort of resources in your hand to solve whatever it is your application requires, and be done with it. Correct? Does that make sense to you guys? Because hybrid cloud is considered as the future, and around you, almost any company that you can name will be using some sort of hybrid cloud. No one usually goes completely private, or no one usually goes completely public. And knowing that, hey, there are certain advantages of both the domains that I would want to use, why do you think people will pass up on an opportunity such as that, right? That's super important for you to know. Now that we took a look at hybrid cloud, what it is and what it does, I think it's high time we quickly take a look at some of its advantages and disadvantages, right? Now, scalability and security are something which differs the public cloud from a private cloud, and we bring those two together, right? You can have the scalability of a public cloud, you can have the security of a private cloud, and you can bring those two together. Now, when you're using the best of both worlds, you have to understand that you will actually end up saving way more money than having individual solutions solutions at hand. Now this differs from application to application, but in the general sense, as I just told you, you can use the best of both worlds and you can find ways through which you will be saving money in both the ways. For example, in a case where scalability matters, you don't have to spend a ton of money for your private cloud. Just whatever heavy lifting, heavy resources are required, just move that to your public cloud, you're good to go. And any sort of data which you would never want to put it in a public domain, store that in your servers. Good deal, right? But one slight risk that happens in the case of hybrid clouds is, especially when you're moving data between your private cloud and your public cloud, there is a very slight risk that there can be data breaches, and your data can be hacked, your data can be manipulated in many cases. It happens extremely rarely, but it has happened around the world. And if there is an advantage, always, if there is a huge advantage as much as this, it comes with a tiny cost. But of course, all the cloud computing platforms in today's world are doing everything that they can to make sure even this gap that exists between your private cloud and public cloud can be built. You can have walls built around your data. It's called firewalls, and you can eventually make sure that unless and until you're authorized to have access to that data, there is no way that you can have access to it, right? So that's really important for you to understand about hybrid cloud. Now that we're done with hybrid cloud, the next thing in discussion has to be community cloud. With respect to community cloud, you have to understand it's very important for collaborative applications, right? Now, let's just say that there are certain users who opt in for a community cloud and they say, hey, there are many companies working in, let's just say, the same industry, right? Maybe manufacturing industry, maybe e-commerce industry or something, where they would say, hey, most of us will want similar levels of performance. I know for a fact that most of us might want the exact security protocols, right, or something very similar too. In that case, you can have a community cloud where one cloud will cater to one industry where there are multiple competitors who are also working and sharing the servers and working there, right? Now, you might ask a question saying, hey, if community cloud is considered, isn't it considered completely public? In many cases, yes, but you can also have it to be managed privately as well. You can have your own server there coordinating with the community cloud to make sure that at the end of the day, again, your data security, your breaches, all of that is taken care of, right? Now, in today's world, community cloud is extremely popular for government agencies. Think about banks and healthcare organizations, right? Now, all of these banks will have similar kind of security authentication. You might have realized you'll have a username, you'll have a password, you'll have an OTP, you'll have to enter a secret password, passcode, identification, something like that, right? So all of these implementation can be done in one community cloud, and eventually everyone can start using that, right? Now, you might say, hey, that isn't very secure, but you'll be surprised at how effective it is. But again, it comes with its own advantages and disadvantages. The advantages is for a fact that all of these things that we say, hey, all these companies use the same authentication protocol, so let's just have one thing, right? So it's not just one random thing that's put into place. It's something which is usually compliant with an industry requirement that says, hey, this has to have the capability to do this. Only then will I and my competitor actually try to use it, right? That's one advantage. The second advantage is that it provides a ton of flexibility, heavy amounts of flexibility through which individual companies can get access to all these controls. They can work with it as they desire, right? But every advantage has a slight disadvantage, and in the case of community cloud, it portrays itself as a bottleneck through which you have one server, let's just say hypothetically you have one server shared by two companies or something like that, right? So the bandwidth of how much you can load up the server and how much you can store data and move things around will be limited because it's one resource being shared with like two companies, right? Now I'm giving you a hypothetical example, but this happens in the real world on the stage as well, because at the end of the day, if you have something and you're sharing it, you don't get to use the full beans. You don't get to give it full throttle and use it all the time as you wish, because that resource is also shared to someone else, right? So you will have a hard limit that says, hey, your bandwidth is only this much. You can only store this much data. And again, think about scalability a little bit here as well, right? So that is where having a hybrid model is advantageous over community cloud. But as I told you, community cloud in many cases is way cheaper than private cloud, and compared to public cloud, it is cheap as well, right? So if cost is your primary concern, I would highly suggest you guys take a look at the community cloud. Now we're going to take a look at cloud computing services. I know you guys are excited to go about learning about these varieties of services and models that we have for you guys, and you have to understand that there are three very important cloud computing services in today's world, right? Type of models basically. We have three things. It's infrastructure as a service, platform as a service, and software as a service. So let's quickly take a look at what each of these are. But before we dive right into one of those to say, hey, this is what this does, let's actually understand the process of how you would go on to choose one of these, right? Now, your first thing should be is to thoroughly understand what platform as a service is, what infrastructure as a service is, and what software as a service is. After you understand the model, you're gonna have some project which says, hey, I have these and these requirements and I want those requirements to be met. Then you compare those project requirements. Once you've understood the model, you can directly match saying, hey, PaaS gives me these many advantages, IaaS gives me these many advantages, SaaS gives me these advantages. So once you know what does what, and once you have a mapping, you can actually jump and say, hey, so I can start setting up my workflows based on which model I picked, and you can start working on it, right? So the process of choosing one at the end of the day is very simple if you're very good at analyzing what's exactly required, what are the future trends, and how can you go on to solve the current problems that you might have had, right? Now, working on these, as I told you, it's not as easy as it sounds, but at the end of the day, if you're very good at evaluating project requirements and knowing what's required at hand, you can figure out a model and you can start implementing it. And having these models, in my opinion, is what gives wings to the domain of cloud computing, right? Again, it's flying across all the charts. Everyone around you is trying to use one form of cloud computing or another, and when that is the case, you have to understand why is cloud computing soaring so high. And in my opinion, these services are the reason for that, right? So let's quickly take a look at what you get to do and what IaaS, or infrastructure as a service, is. Now, infrastructure as a service, wherein you want a service, but as a service you're getting a complete infrastructure. Someone is saying, hey, here is a building for you to move in and you can start working. You don't have to take care about actually constructing the building, buying a land, buying plot for it, planning everything out, constructing a building. All of that is not there. Someone does it for you. The building is ready for you to move in and start using. Similarly, in infrastructure as a service, it's provision of cloud computing resources over the cloud. And here the cloud provider himself or herself, in this case it's people like DigitalOcean, AWS, Azure, GCP, all these guys. They'll say, hey, we'll take up some of the load for you, we'll do some of the heavy lifting so that you don't have to worry about a lot of things, and you definitely can go on to work on things such as logic or actually building your application. So what the provider supplies is things like infrastructure in terms of storage, in terms of networking, in terms of hardware, and a lot more. IaaS is considered to be very popular, and it is portrayed to show a growth of around 40% in the year 2021 alone. Even though right now it might not be the most popular model out there, but I definitely think you guys should take a look at understanding IaaS seriously, right? When I say IaaS, it's basically IaaS, or infrastructure as a service, right? So this is very important for you guys to understand. In terms of infrastructure as a service, what it is that you'll have to manage and what is it that the cloud manages, right? Take a look at on the left side what you manage. Here you'll actually be working on your applications. You'll be taking care of all of your data that's required for your applications, all the runtimes. When I say a runtime, maybe you want to run Python code on the cloud, right? So you require a runtime for Python to work. You require the interpreter for it. And when you have to run all of these, let's say in a Windows operating system, you're going to require the operating system to manage, right? So you have the flexibility to say, hey, I want this operating system, I want to run these many runtimes on it. And of course, since it's your own application, you cannot have the cloud computing guy maintain your give you data to use for your application. You yourself must have your application, and you yourself must have the data that supports and helps your application work. This is what you manage in IaaS. But what does the cloud computing platform manage? Well, they are providing you servers for you to use. They are providing you storage methodology. They say, hey, we'll give you 30 terabytes worth of storage for you to run this application or something like that, right? So Everything from servers, storage, authentication protocols, networking, creating a bridge to ensure that those servers talk to your applications, and everything, even including the concepts of virtualization, is what they will manage. So you will have to configure things on this side, on the right side of things, but at the end of the day, you will never have to set all of these things up from scratch, right? So this is IaaS. And when you take a look at the next thing, which is platform as a service, which is PaaS, as it's also called, again, here is where you're not getting an infrastructure as a service, but you're getting one platform as a service. Think of it as a part of the infrastructure, right? When people tell you, hey, you have an apartment building and it's already constructed and ready, and if you're just going to pick that up, that's IaaS, that's infrastructure as a service. With respect to platform as a service, people will say, hey, there's an entire apartment building ready and we can let you have access to the third floor. Whatever happens in the third floor, it's yours, right? So you have one tiny platform in an entire infrastructure for you to use. Here the similar analogy applies, wherein they are providing you certain resources, just like IaaS. They're providing you a couple of resources through which you can manage your applications, you can manage your portfolio, whatever it is that you're trying to run. You can have multiple frameworks, multiple languages, and knowing that there are certain things, knowing that, hey, someone is providing an entire platform for me to use, you as a developer will not have to break your head about all of these things, which eventually would have taken your time and your resource, right? With this, you can actually sit and work on actually solving the problem. If you're writing an application, think about it. Why are you writing the application? Someone has a problem, your client, your manager, your company, someone has a problem, and you're trying to solve that problem using your application, right? So you will have more time to focus on actually solving it and making it better, rather than figuring out how things work or how all these mundane things which tend to just keep the boat afloat, right? Things such as AWS EBS basically stands for Elastic Beanstalk. We have the Google App Engine, we have Apache Stratos, we have so many of these individual entities that are considered to be very good PaaS offerings in today's world, right? PaaS is something which is very good, even though the analogy where I told you, saying, hey, someone would just give you a tiny part of an apartment building rather than the entire building. You have to understand that when they are giving you a tiny part, everything else that's required to run that entire building is managed by them. All you have to do is take care of your application. All you have to do is take care of your data. And of course, they cannot do this for you. Again, it's your application, it's your data. But once you figure out saying, hey, if I just have to concentrate on my application, if I just have to make sure that I provide data to my application, you have reduced all this load. You don't have to worry about servers, you don't have to worry about operating systems, you don't have to worry about setting up runtimes, breaking your head about networking, breaking your head about storage. You don't have to set up any of these from scratch, because that is what the provider there is doing for you. Of course, you might have to configure and you have to tweak a little bit of things to make sure your application talks to that service at the end of the day, but you don't have to buy any of that, right? So that apartment example, the building example that I gave you, I hope it's slightly more clear now, understanding what it is that you'll have to manage in the case of IaaS and in the case of PaaS as well. Great, that's platform as a service. Now, what is software as a service? Software as a service is basically a concept through which you can have softwares, again, which are nothing but applications, and these can be hosted on a cloud computing platforms. As a user, the user should not be concerned about what happens in terms of software upgrades, what happens in terms of hardware updates, and all of that, right? The biggest advantage of software as a service is that you're getting an entire software through which you can work, so it doesn't require any sort of installation of any applications on your actually already existing infrastructure. You have something that's already working, and once you try to use SaaS, all someone's saying is, hey, we are giving you an entire software. You don't have to do anything. You don't have to mess with your own architecture to make it work, and you just have to use you'll get to use all the features of our software, and you can use it as a service. Think about all these Google applications. Think about Gmail, think about Google Photos, think about Google Drive, think about Dropbox, think about a CRM such as Salesforce as well, right? So all of these work on a software as a service model, because they're just giving you one software that's an entire service that they're providing, and you at the end of the day have the capability to basically work on a lot of different things. And knowing that having an entire software wherein you might not have to mess with your existing infrastructure is critical, right? So here, Think about Google Photos, think about Google Drive. All you do is you move your data around, right? So everything from their own applications, their server, storage, runtime, virtualization, OS, networking, data, everything is managed by them. All you do is you move your photo to Google Cloud. But do you actually have to be concerned about where you're storing the data in the Google Cloud? No, it can be anywhere. Right now I am in India right now, and it doesn't mean that as soon as I move something to Google Drive, the photo gets stored in the Indian server. For all that I know, it might get stored in a server, it might get stored in the Google server that's in Dubai, that's somewhere else on the other part of the world, like in the United States of America or something like that, right? Think about it. You don't have to break your head even on the levels of data, even on the levels of application, because if you're using something like Salesforce, you can use their own software, their own platform to create everything that you require. That you're seeing that moving from IaaS to PaaS and now to SaaS, which is software as a service, the cloud is doing more and more and more, right? When it is doing a lot more, it is taking off every burden that you see on your screen right now. Even though I say I say it as a burden, because at the end of the day, you're going to require a ton of people to handle servers, maintain it. You're going to require a ton of people to work on storage. You're going to require a ton of people to work on networking, virtualization, operating systems, all of these things, right? So you have to keep all of this in mind, especially with respect to SaaS. So we can come to a section wherein we can discuss which of these is the most popular model. We spoke about IaaS, PaaS and SaaS, IaaS, PaaS and SaaS. You might be wondering, hey, so in today's world, which is the most popular service model that we have out there? Well, when you're talking about the most popular service model, you really have to understand who it is for, because IaaS, the network professionals are going to be the ones who are considerate, who will be using IaaS a lot, because they get to have access to those many things, right? With respect to IaaS, the cloud manages some things and the users still have a lot of things to maintain. So network professionals prefer IaaS. And when it comes to PaaS, people who say, hey, I only want to take care of my data, I only want to take care of my application, rest I really don't want to be bothered about, I can offload all of that to someone else. In that case, PaaS is useful. But let's just say you're not a developer, you're not a network professional, you want to use cloud computing platforms, but you don't want to have any sort of technical knowledge. Using Google Drive, you don't require any sort of coding experience, right? You open Google Drive, you log in, you just move your photo, you click it and drag it on your mouse. It's as easy as that, and just put it in their platform. Similarly for Salesforce, of course, you require a ton of training to work on Salesforce itself, but at the end of the day, you don't have to think about how Salesforce was built, or you don't have to sit and code about Salesforce to just learn about Salesforce or something like that, right? The analogy is similar here. If you're an end user who just says, hey, I want your entire software as a platform in itself, and I just want to start using that, SaaS is meant for end users. But in today's world, when we talk about the enterprise world, when we talk about what these big guns, what are the Fortune 500 companies using and what they prefer in today's world, you have to understand that platform as a service gives you the best of both abilities, right? It brings you a lot of advantages of IaaS, and it also gives you the flexibility of SaaS. That is the reason 35% of the entire workload that you would see on the cloud computing platforms in today's world is basically people using platform as a service, because this is the most popular one. And at the end of the day, it doesn't mean IaaS doesn't work well, or it doesn't mean SaaS doesn't work well. Depending on what it is that requires usage, depending on what proficiency, what your application is meant to do, or what level of flexibility you require, this is how the trend goes, right? But of course, as we're seeing, people do prefer PaaS over a lot of these things, but you will see that even SaaS and IaaS are quite popular there as well, right? So to give you a quick understanding, to quickly brush up on all of these things that we just discussed right now, think of the case of making, think of the case that you just want to eat some yummy biryani, right? Biryani is a very famous Indian dish. Now, when you take a look at biryani, if you are trying to have an on-premise server, it's like you saying, hey, I'm going to do all the shopping for all the materials which are required to cook biryani. I'm going to do it myself at home. I'm going to prepare it. I'm going to cook it. it, I'm going to eat it, I am done. Everything at home. That's similar to having an on-premise server. Now, with respect to infrastructure as a service, basically all you're trying to do is you're taking ready to cook biryani sets. You know that you'll find those packets on your supermarkets and all of that, and those kits will give you certain things to get started with the biryani itself. But you should still come home, you have to still cook it, you have to maybe mix the masala and do something a little bit. You're doing only a little amount of work rather than everything, right? And eventually you still get to eat biryani, right? Now think about PaaS. Platform as a service is basically you guys saying, hey, I'm going to call Zomato, Swiggy, or any of these popular food delivery apps like DoorDash, and if you guys are watching this from the US or something, where someone has already cooked the biryani for you and your job is to just sit and eat it. Your goal, in fact, is to just eat biryani. How you eat biryani is very important, right? You either cook it from scratch, you just bring a ready-to-eat kit, you do some of the work, or you have someone else do it completely for you and you just sit and eat it. That is PaaS. Now thinking about SaaS, software as an entire service is basically you just walking into your favorite restaurant and you just wanting to sit there, eat biryani, and you're done. Your goal is met. So you're just moving into your favorite restaurant, you using on the lines their software to actually sit there, make sure your goal is met, and you eventually come out of that application, come out of that restaurant, right? Now talking about all of this, biryani definitely has made me a little more hungrier, if I can be honest with you, but I really hope that understanding cloud computing services this way will actually help you have complete clarity on what it is that we just spoke about all this while, right? Alright guys, so let's get started with platform as a service and let's have an in-depth look now, right? We took a look at a lot of things. We took a look at introduction to cloud computing. Why is cloud the future? What are the types of deployments there are? We understood a lot about private clouds, public clouds, how it works with your on-prem network, and a lot more. We understood how the domain of cloud computing itself works on the lines of middleware, front end, back end, and all of that. And right now is the time where we can dive right into PaaS and understand it to a good amount of depth. Right now, as we checked out in the previous section, PaaS is something, it's a cloud computing model which is extremely popular in today's world because here in PaaS, basically the provider is delivering almost everything that is required for you guys. He's delivering the software, the applications required by the platform, and the actual hardware, again, through which you'll be accessing the platform, are given over to a client, and again, by making use of an internet, as you already know it, right? So basically hosting all of these softwares and hardwares, right? The provider itself is giving you an infrastructure through which you'll be using that. Now you might be saying, hey, so if the platform developer or the provider is giving you everything, why do we even have to consider PaaS? Let me tell you this. As a developer, as a person who's who's looking forward to writing code, creating applications, taking prototypes all the way to product, your key focus, your key working area will definitely be on your actual software, your data, your application, right? So offloading everything else, right, from networking, security protocols, hardware, software, maintaining all of these, and thinking about all the things that we saw to the introduction to PaaS section, right? You will definitely figure out saying, hey, this is taking out a chunk of load, a huge load is being offloaded from the developer side, and they can spend their good amount of time to actually work on critical tasks in which they have expertise, rather than breaking your head about, hey, what firewalls are being used, how do you get that to work, how do you move data around. You don't have to really worry about any of the hardware, maintenance of that hardware, and the software which is required, operating systems for example, right? You don't have to sit and worry about operating systems there as well, right? So all that is offloaded off your shoulders. Now, a common question that I get asked every time I go to teach PaaS to someone is, hey, since you're getting an entire platform as a service, apart from applications and data, the client would not really be bothered about a lot of other things. Does it mean that you can take an entire company's infrastructure and actually replace it just with PaaS? Well, not really. It is actually a complement to the network that might already be established in the company or the individual's place, but it cannot completely replace it, right? PaaS is talking about how you can deliver a varieties of services, basically using public clouds, private clouds, and even in a hybrid environment, PaaS works absolutely beautifully, right? The The goal with PaaS is of course to help you take an entire infrastructure up to the cloud, but the main idea of implementing PaaS is to make sure that you have a structured pipeline through which you can have your development team have very good collaboration, make sure that you have a structured set way of how you can create good information security policies, and of course work on a pipeline through which application design and development can happen in a structured way, right? So that is something which is very important for you guys to understand at this moment of time. Now, with this, you might be very curious to know more about PaaS, and the general sense always tells you saying, hey, if we're getting platform as a service, how do you directly compare it to infrastructure as a service or IaaS, right? Now, when you compare PaaS directly to IaaS, right, with respect to infrastructure as a service, you do get a considerable application stack, but at the end of the day, with platform as a service, the provider has to maintain a lot more on the back end and has to keep things running, and you will just have to be bothered about your application and data. So you're offloading more while having more options to work with, right? And it never is the case when you're taking your company to the clouds to say, hey, I need only one runtime, or I'm gonna have as minimal a middleware as possible, right? It doesn't work that way. You might have to have multiple runtimes, and you might have to work with multiple middleware. Now, when that is the case with respect to platform as a service, as I just told you, integrating all of that and bringing it to your stack it's not your responsibility, is not your key area through which you'll definitely be working on that, right? It's the cloud provider's responsibility to make sure that he or she has the platform ready for you to consume, right? That's very that's very important. How well structured the app is, how well structured their services are, is what makes a difference at the end of the day. Now just think about Amazon Web Services, EBS, right? Basically called as Elastic Beanstalk, and think about the Google App Engine as well. Now all you are concerned as a developer is to take your application and of course all the data that is supporting to the application and eventually getting it to work and solving the purpose at hand. You would already know that Google App Engine and EBS are already ready services which will work, which will help you solve the implementation. But at the end of the day, just by making use of EBS, you really cannot do a lot unless you have your application or services running the way you want to trying to solve the problems at hand, right? So you have to understand that you're just moving one more step towards convenience with respect to PaaS, because you have a lot less to manage and the platform has a lot more to manage. In the case of SaaS, to be honest with you, everything is offloaded to the cloud provider, right? Think about Google Drive, think about think about Salesforce, right? You're using their software. Their entire platform is given to you as a service at the end of the day, but it is not PaaS. It is an entire software that you have at hand through which you're going to be working on it, right? So it becomes super important for you guys to understand that convenience wise and logically speaking, you're one step ahead of infrastructure as a service. But if you are a person who would need that kind of a flexibility in terms of your data, in terms of in terms of how the operating systems work, you want some visibility on how things are going on, it depends on the platform, but you have to understand it. With respect to PaaS, that might take a little hit, right? But that doesn't mean that it is in any way low compared to SaaS or IaaS, or in fact it has many advantages, right? So with respect to working on IT services and with respect to simplicity and convenience, I don't think there is nothing that will come close to beating PaaS, because at the end of the day, everything right from all the advantages of cloud computing with the heading being pay as you go policy, because this at the end of the day will ensure that your entire capital expense that you have to put forward is going to tank a lot down. And for individuals, startups, and people who are just looking forward to moving to the cloud and or maybe away from an on-premise server setup or something like that, this will be the biggest point of why they would even think about considering PaaS, right? And it's not just money, it's not just convenience. When you think about it, all these PaaS solutions we have in today's world are offered by platforms who have amazing uptimes, right? We know for a fact that if you're taking your entire company to the clouds, and if there's a downtime of a couple of minutes, there's a very good chance that you will take a hit on your revenue worth thousands if not millions of dollars, right? It rarely happens, but it has happened in the past. Now when it is so critical on that league, right, where you're losing millions of dollars through no fault of your own, just because your provider's your provider's network fell through, or at the end of the day there was some issue with your server or something like that, through no fault of yours, you can lose money as well, right? But considering these PaaS solutions we have today, with every passing day the uptimes are just going up and up, and at the end of the day that has to mean a lot, right? But when you think about advantages, it's a good thing, but there are certain disadvantages here with respect to PaaS that we'll have to take a look at, right? Now, moving from an entirely different way of working to PaaS can sometimes affect the client adversely. When you think about, when you think about actually migrating, right, it becomes very difficult. Let's just say today you're using AWS, you're all set up with their services, it's working fantastically well, and tomorrow you say, hey, maybe Azure or maybe GCP is providing something at a better price, or they're providing services wherein you just want to move your entire base over, you want to migrate everything over to their the different vendor, right? So with respect to PaaS, this concept of vendor lock-in comes into the picture, because at the end of the day, if you are if your future, when you say I want to switch providers and vendors, it becomes very difficult to migrate all these services from one PaaS vendor to another, because the fundamental working can at the end of the day be very different, right? How Google App Engine works is very different from probably how Elastic Beanstalk works. So you have to keep all of this in mind definitely before taking that leap into PaaS and thinking that, hey, maybe if I just have to move, it all works the same, right? So jumping should be easy. It is not that way, right? So another very important thing about PaaS, which is concerning to some people, is the fact that how the entire infrastructure works is hidden from the users and developers, right? They have given you a very well-rounded service which works absolutely beautifully. But one very important thing you have to keep in your mind is that when you're using a PaaS architecture, right, the entire infrastructure is actually hidden from the users and developers. Now, if you're a person who's very inquisitive and you feel like, hey, now, yes, it's a very well-rounded software, it works beautifully well, it does everything it says, but how does it work and why is it working the way it does? If you're a person who's curious to understand how the infrastructure itself works, that at the end of the day is hidden from you, right? You are given a service which is working really well, it is doing its job, but at the end of the day, if you want to figure out how it's doing that, why it's doing that, and if you are inquisitive about it, it does get difficult, because again, it's very much dependent to the platform itself, and these guys don't really, with respect to how PaaS works, they don't have to reveal to you how their platforms work, right? Give it a thought. That is not a disadvantage, but again, if you require that flexibility, it definitely can be considered as a disadvantage, right? So if you require that flexibility, 90% of the cases when you pick up PaaS, you would know this in depth, but since you guys are learning this at this moment of time, you have to understand that it's critical while making a decision, thinking about which model to pick up. If you look at the advantages and disadvantages of IaaS, SaaS and PaaS, this one point, the flexibility part of it, does come into be a small amount of concern for a lot of people apparently, and I thought it is worth a mention for you guys, right? Now, the next section, we're going to be discussing the various types of PaaS that are out there in today's world. Now, when you think about PaaS, there's 4 popular offerings, guys. We have public PaaS, private PaaS, hybrid PaaS, and communication PaaS. Now, at the end of the day, we saw the various types of deployment, what happens in a public cloud, private cloud, hybrid cloud, and all of that. The working here is very similar, right? So with respect to public PaaS, at the end of the day, as the name itself suggests, the platform as a service, if it's public, it is meant to be used with a public cloud-based solutions, right? So here you will have control over the software deployment, and at the end of the day, everything else apart from your app and data is taken care by the providers, such as operating systems, networking, security, authentication, database management, everything, right? So all of that you really don't have to break your head about in terms of hardware, in terms of software, or even middleware which talks to your app, right? So popularly, whenever the discussion is about public PaaS, you have to understand that it can work really well on top of another IaaS architecture on a public cloud, right? So let's just say you have a company, you have a product that is set up, and you chose infrastructure as a service, and you would know that you will have slightly more control in terms of what you can do. But guess what? You can actually have for public PaaS work on top of that, wherein you would say, hey, for this role, this application, this part of the product or this prototype, I really want to offload a lot of the stuff to the cloud computing provider, and I just want to have focus on my app and data that powers the app. In that case, yes, on top of an existing IaaS architecture, you can actually get PaaS to work as well, right? That's a good advantage. Now think about private PaaS. Private PaaS again will give you all the features that you required of public PaaS while keeping things such as security and all the benefits that think about the benefits of private cloud that we discussed, right? There are cases where you would not want your data to get out on a public platform. You're saying, hey, no, I want the data to be in a private cloud. I want my own server, my own farm through which I'll store the data, right? Security is the primary concern. Now, when you think about things such as that, the advantage with private PaaS is that it will give you everything, the entire flexibility you get from public PaaS, and at the end of the day, you get added advantages in terms of security, in terms of all the benefits that it brings, right? So it is amazing to understand, because once you have a platform as a service, and especially if you're considering private PaaS, the entire thing gets deployed inside the user's firewall, right? Firewall is basically like as the name itself says, it's like a wall. Think about it like a huge wall, right? Nothing can get in, nothing can go out unless it is required and authenticated. Now, usually in public PaaS, things move around outside the wall a lot, but with respect to private PaaS, things happen inside the firewall, right? In many cases, it is extremely common to find this kind of a solution where people are using on-premise networks, even though it's not completely private PaaS, but the concept, the foundational ways of how things work there, that is still private PaaS, right? So again, in many cases, private PaaS is put into effect wherein people would say, hey, I would still want to work on my application and all the data, but at the end of the day, I also want strict privacy requirements, and the client says, hey, no, you cannot put this data out there for the world to see, or you would not put the data out on a server through which someone else is using it as well, right? Certain high standard of security requirements there too. Private PaaS is seen as hugely advantageous. Then think about hybrid PaaS, right? Hybrid PaaS basically is a combination of private and public PaaS offerings. Both advantages from public PaaS and private PaaS, as you already saw with respect to hybrid clouds, are used here. And to be very honest with you, there was a time when private PaaS was the most common way, the most popular one. But today, people do want to look towards hybrid PaaS, right? They want the hardcore computing power. They want really large resource set from a public cloud, yet at the same time they want the security features of a private cloud. And we already saw that it is really possible to do this. You can have all this critical nature data on your private network while you can still use the compute resources from a public cloud, right? It is very much possible, and this kind of a flexibility, security plus access to a ton of resources at cheap is what is having the PaaS domain to actually fly about, as we see that. And of course, as the name itself suggests, it is built in a fact that it will work really well with all the hybrid cloud deployment models that we have. Now think about communication PaaS. Communication PaaS is sort of a novel idea here. It's also called as CPaaS, CPaaS, as you can see on your screen. And this is gaining rapid momentum in today's world, because at the end of the day, sometimes you require real-time communication, right? You will require real-time communications wherein your applications are actually using a lot of resources, and that shouldn't create a lot of lag. That shouldn't create a lot of time gap, right? And in most cases, you will think that, hey, if anything is real time, right, like a live session, or any part where you're talking and the other person is hearing, it does take a good amount of resources. Think about the cloud part of it now. It takes a huge, heavy infrastructure to do it, right? But guess what? With respect to CPaaS, you really don't have to worry about all of these things. Now, where would we use communication PaaS? Anywhere where real-time communication is happening, right? Think about WhatsApp. WhatsApp is where we're doing instant messaging, right? It's an IM protocol. Now, when we're doing instant messaging, name itself says instant, right? If I send you a message, if you get it after 10 minutes, it's not instant anymore. Would you still prefer using it if there was that kind of a huge gap there? I don't think so, right? Think about Skype, think about FaceTime, think about Zoom meetings, think about Google Meet or anything, right? Where as soon as someone says something, the other person, of course, it's going to be a tiny amount of lag. In our case, we can call it negligible, right? It's not like I say something, you have to sit and wait for a minute to hear what I've said. So that couple of milliseconds or 1 or 2 seconds of lag is completely acceptable, and getting that to be done without having heavy infrastructure to back that process up, right? It sounds very simple to have real-time communication, but when you're actually trying to implement it, especially on an on-premise network, it's really a pain, because at the end of the day, you require that kind of horsepower to actually have your networks open to a fact where people can communicate constantly without there being any noticeable lag in the picture, right? It is very difficult. But of course, with respect to CPaaS and with the amount of firepower the world of cloud computing has today on the lines of AWS, Azure, and GCP, we really don't have to worry about any of these anymore. All you have to do is try to implement the logic of it and leave all the heavy lifting to be done by these platforms, right? Fantastic. Now we're going to take a look at what are some of the, who are in fact some of the various providers, the top providers of platform as a service in today's world. As you would already guess, the 3 top names should be there, right? Amazon Web Services, Google Cloud Platform, Microsoft Azure. Now these 3 are leading the majority of the cloud computing stake in today's world, but it is not only these 3 guys. You have various other options as well. You can consider IBM Cloud, you can pick up Red Hat and IBM are basically similar things. Now when you think about Heroku as well, right? Heroku is also giving you great access to services, which at the end of the day, you do have various options. That's the entire point of telling you guys about these top providers. Now whenever I talk about IaaS, SaaS or PaaS, everyone just brings and quotes up service examples of AWS or GCP or something and says, hey, these are your options. Not really, not anymore, because at the end of the day, there's more and more platforms coming into the picture to compete with these big guys, and these guys are offering relatively cheap prices. Their services are really good and it works well, right? Now, when that is the case, you have to understand that you have the flexibility, and let's be honest here, if it's a cloud computing solution, especially on the world scale, especially on the Fortune 500 scale, no company would be using only one, right? No one would say, hey, I have my entire infrastructure set up in GCP. Maybe they do, but at the end of the day, they will be using services of GCP, they will be using certain services from AWS, and they'll be using certain services from Azure at the same time. The same company, we have many examples of people who do this. But now with respect to PaaS, that kind of a flexibility in terms of just offloading everything to your provider and just working on your application, right? You can make use of resources from other people such as Red Hat, Heroku, and IBM Cloud as well. Now this is something really important for you guys to understand. And once you've taken a look at this, to wrap up our entire discussion on PaaS, one important thing is that we have a lot of unanswered questions about when you should consider PaaS. What are some of the most critical things that you have to understand, right? Now, the first thing, the absolute first thing whenever, in the things that you should consider when you're looking at PaaS is for a fact that you have to understand what are some of these really important features that are being provided by the provider, right? Think about it. Because once you go on to, use PaaS and you fix up your mind, your product works really well in this kind of a service architecture, at the end of the day, yes, it's a good thing, but you might be limited, right? Now, whatever AWS provides in terms of its PaaS offerings is everything that you will get. As I just told you, right? Sometimes it's a mishmash of all of these various cloud computing providers. That is how the world works. It works really well. But at the start, if you're not sure enough of where your application is going, or if you don't have a future track in terms of development abilities and deployability, what happens is for the fact that you might have picked up one provider, later down the line you realize that there's someone else who's giving you a better service, right? Then migrating is again another huge pain. So you really have to keep in mind, and the most critical stage of choosing a service model starts here. What are these features that they are giving? What are some of these features that will directly work in your favor, right? You have to think about that. What usually people consider, right? Whenever you're choosing PaaS, people will say, hey, these guys are providing these many so and so services. This will work really well to develop my app. But that's great. Developing your app should be your primary concern, true. But at the end of the day, when you are developed and you have your app deployed, don't you think you should also be equally concerned about growing that application? Today, 100 people are using your app, and what if tomorrow you go viral and you have 10 million people who are coming to use your app, right? In terms of your own invoicing, in terms of billing, in terms of what, how much of horsepower can the service provider even give you at the end of the day will matter a lot, right? So you really have to think about the long term before considering PaaS. And as I told you, migration is out of the picture. Migration is pretty difficult, but you have to also think about the fact saying, hey, I am an entrepreneur maybe, or you're a person who's just starting out, you're a startup individual, whatever you are. You have to also consider things that saying, hey, today, yes, there are 10 people. What if my product gets 10 million hits tomorrow? You would definitely want to expand your team, right? So how easy is it to add more users, and how easy is it for you to say that, hey, scalability will not be a worry for me when you're using PaaS, right? Because scalability is the primary concern whenever someone has to pick up any of these service model, to be honest with you. Because if it is not for scalability, you can run everything on on-premise network and still be happy, because you know that, hey, my server can handle 1,000 hits of traffic. I know that I'm only going to get 1,000, so I'm done. If tomorrow you're getting 10,000, you chuck out the server, buy another one, right? But until it gets to that point, you don't have to worry about it. And usually people, have this kind of a tendency whenever looking at PaaS as well. But you have to understand that scalability is really not a problem in many of these cases. But you also have to think about, since it's very platform dependent, you have to think about how AWS is doing it. You have to think about how GCP or Azure is doing, and how it aligns. This is the important part, how it aligns with your own requirement, right? That's very important for you guys to consider. Now, as I told you, if you're a company who's running everything on the cloud, runtimes can be an issue, right? If your platform is not optimized to run, let's just say, a language such as C# or something like that, and your critical application works on C# .NET or something, or you are running a framework or a language which the platform doesn't support, right? Maybe you didn't know this while picking it up, but at the end of the day, when you think about it, runtimes will be a huge issue if your platform is not optimized. It doesn't mean it doesn't support it. It does support it, maybe for a fact that it is not optimized enough for it, right? So that is something which you have to consider as well. And regarding the platform, the second point is not a lot of concern to everyone these days, because we know AWS, we know Azure, and we know that GCP are the guys who will be leading the industry now, and there's a very good chance 10 years from now these guys will still remain the leaders, seeing how things are going. But is the provider giving you this kind of a long-term overview which is needed for the platform, for your application? Are they giving you visibility to tell you, hey, 10 years from now this is where our platform will be, we're probably adding a ton of more services for you, we are dropping the prices down, something like that, right? You require that visibility. If you're saying, hey, I'm going to be requiring your entire platform, and I want it delivered as a service over the internet, this is something that you have to consider. And when you're adding more people in a PaaS environment, let's just be honest, right? More people, more teams, more collaboration, which will always lead to specific coding requirements, right? One team says, hey, I'm working on Python. The other team says, hey, I want to work on JavaScript. And you have to make sure that your application doesn't really slow down at the end of the day. With respect to PaaS, there are certain situations where your application can slow down, and again, the next point you'd be considering is migrating to someone who has interlinked services which work faster, right? So more users, more specific code requirements should be a concern, but it would not be your primary thing that you'll be looking at, right? Of course, it's a very important thing at the end of the day, but what you really should be looking at is the long-term growth. You should be looking at the service, the various services that the platform is providing to you, and how are those services being developed, and what are the future prospects of those as well, right? So these are some of the things which really govern how PaaS works, and at the end of the day, not just how PaaS works, how you can implement and use a cloud computing model which works for your application, right? So guys, this is very important for all of you all to understand. Now, to quickly summarize everything we have learned, we started out by understanding what cloud computing is, why we require cloud computing. We understood the core reasons of why cloud computing is so important in today's world. After that, we understood the various types of cloud deployment. There are public clouds, private clouds, hybrid clouds, community clouds, and a lot more, right? Now, once we understood that, we took a look at having an introduction to the various deployment models in terms of services, infrastructure as a service, platform as a service, software as a service, right? we took a look at how each of these work, what you should manage, what will the cloud provider be managing, and we tied it up with that very nice biryani example, right? Think about it for a second, and that will help you remember it for a really long time, I'm sure. Now, after that, we dove right into understanding what PaaS is. We had an introduction to it, we understood what it is, where it is popularly used, all the top providers out there, how it works to a good amount of depth, and some of the really important things you have to keep in your mind if you are going ahead to consider PaaS for your cloud computing requirements, right? So we made sure to take a look at all of these things, and I hope that everything I've covered in this course is clear to all of you all, right? On that note, thank you so much for completing this course. My name is Anirudh Rao, and I'm more than excited to see you on the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.